Welcome everyone, I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 2461, which is maximum sum of distinct subarrays with length k. Let's see the problem statement. You are given an integer array nums and an integer k. Find the maximum subarray sum of all the subarrays of nums that meet the following conditions. The length of the subarray is k and all the elements of the subarrays are distinct. Return the number of return the maximum subarray sum of all the subarrays that meet the condition. If no subarray meets the condition, return 0. A subarray is a continuous non-empty sequence of elements within an array. So we basically need to find the subarrays of length k in which all the elements are distinct, and we have to calculate the sum, and we need to find the maximum sum out of all the possible subarrays which match the following conditions. And the constraints are k will be less equal to length of nums, and the length of nums will be up to 10 to the power 5. Each of the element present in nums will be up to 10 to the power 5, and our return type is long. So first let me use LL is long. So to solve this problem, we will use map. So to like count the frequency of each element in the subarray of length k, and we will check if the map dot size is equal to k or not. If the map size is equal to k, that means there is k unique elements present in the subarray, and if the map size is less than, so we will not update the answer. Okay, so let's start. So LL answer initially 0, and also we need the current sum, so let's say sum is equal to 0. This sum will be calculating the current sum or the sum of the k element. Okay, and this answer will contain the maximum sum out of all subarrays. Okay, so for int I equal to 0, I less than nums dot size I plus plus, and you can see we have to find the subarrays which have the length k. So we need to use the sliding window technique also, so that when we reach the length of k of subarray, then we need to exclude the leftmost element of that subarray, so that after the in the next iteration when we add another element, then the like length of the subarray becomes k again. Okay, so first we need to add, so let me make the unordered map. So on unordered map, the type will be int comma int, let's say mp. First we need to insert it. The current element is nums of I plus plus, and the sum is plus equal to nums of I. Now we need to exclude the left hand leftmost element if the length of the current subarray is k, and the length of current subarray will be k whenever we have excluded or we have reached the at least length k. To do that, we need to check if the number of elements which we have visited, the number of elements is I plus 1, because I starts from 0. So I plus 1 is the number of elements. If it is greater or equal to k, that means we already have k elements in our current subarray. If it is true, then we need to check if the map dot size is equal to k or not, which means is there all elements are unique or not. If it is unique, then update the answer. The answer will be max of answer comma the current sum, and otherwise we need to exclude the leftmost element of the current subarray. So the leftmost element is, let's say, nums of I minus k plus 1, and we need to exclude that. So mp of value minus minus and sum minus equal to value, and we also need to check if MP of value is equal to 0. If it is true, then we need to erase the value. So MP dot erase value. That's it. After the for loop, we will have our answer. And as we have initialized the answer with 0, so if there is no subarray fulfills the condition, then the by default value of answer is 0, and we need to return 0 also in our answer if we do not find any of the subarray. So we need to just return answer. That's it. Let's see will it work or not. It is accepted. Let's submit it. So it is accepted. Let me discuss the time and space complexities of this algorithm. So the time complexity of this algorithm is big of n, where n is the length of the given array nums. Because for each of the elements, we are traversing the whole array. So that's why the time complexity is big of n. And space complexity will be big of k, because in worst case, there will be like maximum of k elements in our unordered map, because there won't be like greater than k elements, because if the length of the subarray is becomes k, then we are excluding one element from the map also. So our maximum size could be k. So that's why our space complexity will be big of k. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.